Hey guys, Jonathan Feist here for Drone Rush. We're recently back from AUVSI Xponential in Denver. We learned a whole lot about the drone industry, or the UAS industry, and we learned a lot of it from one company, Intel. Now, fair warning, if you came to this channel looking for drone racing and fun retail drones, this video is not for you. However, if you're interested in the greater workings of the drone industry, we attended several Intel events at Xponential, and we found that Intel really has their hand on the pulse of the market. Now, no matter what company you're dealing with or what drones, you're about to spend the next 20 minutes listening to a great interview with Anil Nanduri, Vice President and GM of the Drone Group and more at Intel. He will explain Intel's approach and their Intel Insight program for inspection services and mapping, but please listen to Anil and get a feel for the industry. He expresses the same opinions, obstacles, and technologies as almost every drone vendor we met with at the show. Bottom line, if you are doing anything more than just flying a drone for fun, you should check out this video to see what Intel is up to.
I think Interdrone was a great, our CEO, Brian Krasanich, did a keynote there. And what we're trying to showcase is how drone technology can solve real world problems. And we are focusing, when we talk about problems, it's about the commercial use cases. We are talking about inspections, inspections of infrastructure. You're looking at surveying. You're looking at inspection of oil rigs or bridges, or in terms of power transmission towers. So when you think of it from that aspect of it, when you look at the drones is a means to capture the data. It's a critical piece of it. But the main transformation we are looking at, how drones can bring value in this commercial space, is then, okay, how do I then leverage it? The customer cares only about three things. Okay, is it going to do the job I need? Is it going to do it more efficiently, faster, and safer and cheaper? Right? So the technology should be the means to achieve that. And we see drone technology as the capability and the promise of getting there. But when you really look at how drones are changing that workflow today, so if I'm doing an inspection, whether a person is climbing the tower and actually physically inspecting that today, or they're using other kinds of equipment to go inspect, having the eyes in the sky from an aerial view, getting close to that object, is by far the most efficient way of doing it. But you're now getting data, and you're capturing some, whether it's a thermal image, or you're capturing a high resolution image, or in some cases, use cases, you want a multispectral, so look at vegetation or some aspects of it. Now that's data. So what do you do after that? So I captured it. Now I need to go analyze this information. Now if it's a single project, like just your roof of your house, you just have one small area, you're going to go look at it, you fly a drone, you get a bunch of pictures, you can manually take a look at it and say, all right, I see some problems, or I don't. But good thing you've done is you haven't put a person up, you didn't have to climb up on a ladder and go check it out, right? Or you can see my gutters need to be cleaned up and aspects of it. It's a simple example of what I'm trying to give. We are talking about complex assets here. But if you're starting now scale this, you need to then say, okay, when I fly the drone the next time, is the data accurate enough? Is it repeatable? And then how do you use technology to harness this data? And what kind of data are we talking about? One flight here, 500 images, I'm already looking at 10 gigabytes. And you do that, 500 flights a day, 75 drones across multiple sites, and you're already at 18 terabytes of data. So you've got to then figure out, how am I going to manage this information? And that's where we spend a lot of time since Interdrone, is that, okay, while the data capture, we spend a lot of time figuring out the drone itself, but the real value starts to come to play when you're now able to harness the value of the data in how you manage it. So now, do I have a comprehensive platform where I can store the data, I can work on it, I can preserve it, I can then start in future to look at detections of changes from one mission to the other, what insight can software and analytics provide to me, and then you're unleashing the power of what the digital transformation is. So that for us is what will trigger the adoption of and scaling of drones in the ecosystem. And the kind of customers, when you're looking at power lines, it's like a PG&E or a Duke or a Southern Company. When you're looking at infrastructure, it could be dams and bridges, and there's both Department of Transportation related versus this private property. So you start to look at, and by the way, even the railways have one of the largest bridge networks, right? So, and they all need to be inspected, right? So we focused, and we at AUVSI here announced the details of Intel Insight. Our CEO at Interdrone had just given a demo of it, but what we are really showing here is that the Intel Insight platform is actually now deployed, and we are deploying it to key customers. It's not open to everybody, but then anyone who wants access to it can make a request at the Intel's drone page. It's online. And then we are really focusing on enterprise right now, and as we mature it and we evolve it, we will scale it, right? So that's the approach we're taking. And what allows for us is the ability to learn, and as customers are looking at how drones can apply to their different use cases, the management of the data allows us to see how technology can actually enhance it, right? And Intel is a technology company. And so we are looking at use cases on how the digital technology and analytics and software can help solve a customer's problem. I mean, end of the day, the customers, we are not an inspection company, so there are customers who need those, and they know that better. But we are here to kind of use technology to solve it. So now if you talk about, okay, what kind of a data management system I need, you want it to be repeatable, you want it to be asset based, so it automatically knows. So if I flew in Portland and I was in this asset here, how do I know that? Because it's all geo-referenced. And once you do that and you upload another project, it automatically tells you, hey, you've already flown here, is it the same asset? Or do you want to treat it as a new project? It gives the power of that flexibility to the user, and you can then choose. That's one amazing feature of it. And whether you want to work with 2D images, you want to work in the 3D workflow, multiple choices. We have industry leading processing engines, both Bentley as well as Pix4D are processing engines in there, and they're leading photogrammetry engines that everybody is aware of, especially in the GIS space. And then the last part of it is, you have different teams. The person flying the drone may be updating the data, uploading the data, but the person who's looking at the data may not be the same and may not be in the same location. So the tool and Intel Insight is built around team collaborations, so you can share between locations, within locations, or across locations. So the data is the customer's data, right? So that's a fundamental aspect of it, and that's another part of why we at Intel look at this, and we look at saying, first of all, the customer owns their data. It's their aspect of it. Now, as regards to if they have, and by the way, there's clearly customer privacy. They shouldn't have flown over someone else's property, right? So it's their responsibility to make sure that the data that they have is to be their own, and there are different processes to manage that. So we don't have to reinvent those processes. But from a solution that we have, where Insight allows you, for example, if you accidentally flew more than you needed, you can actually use, when you upload to Insight, set your boundaries. So you can actually say, what, I shouldn't be capturing any more information. So the Insight can then only upload the data for the area that you chose. So now we talked about Insight, and this is the data management platform, right? But how do you make this valuable? So first, the key glue is you need the drone to capture data, right? So and there's a glue between the hardware and the platform which is flying, and also the data management is what kind of a mission am I doing? So the one other interesting thing is the mission planning. And how do you make sure that the mission planning is allowing you to capture the data so you don't have to go back and fly again? So we also talked about Intel Mission Control. It's a very, very intuitive and three-dimensional based flight planning software. We demoed it here. And again, it's in beta. We are testing it out with customers. It works with our drones, but that allows the data sets that you're capturing from the flight to be ensured that when you're processing it later, that you don't have to go back and you didn't miss any data. So that's a very key part of it. And then the flight itself, the flight platform needs to have the capabilities that you need. So we have a high resolution sensor, and at AUVSI Xponential here, we announced the Sony Rx1 payload. Now what's interesting about this payload here is not only it has a 42 megapixel sensor now, and it's a Sony camera, a full frame camera that people know of. It also comes with an RTK antenna, so it's RTK upgradable in software. So that's a great feature for someone who wants much more higher accuracy, data. The other payload we announced here at AUVSI was one for an inspection, which also has enhanced collision avoidance features. So the two new features we talk about is distance hold and distance guard. How does distance hold work? Very simple. I'm flying, and trying to inspect a tower. Now the pilot who's flying, it's very difficult for him to know his orientation of distance. So he can set physically as he's flying, saying, I want to fly at no closer than 3 meters from the asset. Then the vision system from the drone itself automatically knows that distance, and it holds position. And so the pilot doesn't have to worry about accidentally pushing his joystick or anything else. The other one is called distance guard. Now this is also more interesting when you're flying under a bridge. Sometimes you have GPS variations. You may lose GPS for a few minutes or so. And in that scenario, the distance guard kicks in. Think of it like a bumper. And it makes sure that the drone itself doesn't, hit the asset or something like that. So very useful features from a pilot and capabilities for the pilot in the field to work with. By the way, this technology uses Intel Realsense. So it's actually built into the payload, and we use the Realsense cameras. There are 2 of them that are used to provide the depth information and the 3D information of its environment. So as of today, the Falcon 8 Plus drone has a support of 5 different payloads, and so we have enhanced the amount of offerings, so it's a choice for the customers. And swapping a payload is very easy, right? It's just in the field you want it to be quick, and so and that's all it is. And then you can put a new payload, and it's a single screw. This system has been designed for redundancy and safety, right? There are 8 rotors, and there's no single point of electrical failure. Right? And again, meant to make sure that your mission and your inspection is done safely. So the way we think of it, like I said earlier, we are focusing more on the enterprise customers and in some key verticals, and the verticals like utilities, infrastructure, some construction, and I call digital ag, as well as oil and gas use cases, predominantly where our drones have actually been quite known for and been used. Now, as far as the options are, the customers can get access to the hardware itself, and they can get access to Intel Inside, and especially for the enterprise customers. Now, again, we are here to solve a customer problem. If the customer, we have the ability to fly or even work with partners to fly, so it's an ecosystem. Now, flying the drone, planning the mission is one part of that workflow, right? But if the customer wants all of it to be taken care of, we are more than happy, and we will partner with the right folks so that the customer doesn't need to worry about it. But what we do is provide not just if they need the flight system and they want to process the data, we can set it up that way, or you want to just process the information, we can work on that, because some of them already have captured a lot of data. So that's the good part about Intel Inside, is you can input reference information. So if you have already a LiDAR, so we don't support LiDAR, for example, but if you have a helicopter that flew and captured LiDAR data, you want Insight to be able to leverage that. And so we actually have support for things like that. It means something if we are solving a customer problem, right? And that's what drives us. And so, and the customers in these use cases are varied. And so we are learning from those, aspects of it. What are their pain points? What problems are they trying to solve? And how can technology be an accelerator? It shouldn't be coming across, it's too complex, it's too difficult to learn, now we have to adopt it. We need to make sure that technology is making things easier, not more difficult, right? So what we kind of learn is that, the ability of the capturing of the information, making sure, for example, you fly and you think the data is good enough to go put into Insight. Quite often, sometimes it's like, okay, maybe the images are not at the right focal length. or you flew, there's a lot of shadows. So you start to see some operational pieces as well that need to be baked in, and you kind of see variability, and you need to, and the interesting thing about software is some of it can be corrected in software. Some of it you want to get some reference data. So for example, if you take a simple, on a bright day, and you take a simple reference image that gives you the lighting condition of that, if you have that reference image, you can easily use software to correct all the shadow problems or the lighting problems you may have had, because you've got the right exposure settings, and then you correct it in software. But if you did not have that, you may see some variability because I flew one on a cloudy day and one on a sunny day, and the two data sets are not exactly matching in software. So there are all these things that you're starting to learn and see how you can kind of tweak and evolve it and make it easier, right? The end of the day, customers want it simple, right? Hey, I shouldn't be learning, the drone should be smart enough to know how to fly and collect the data, and it lets me know that I captured all the data. So this is one of the biggest points, is I don't want to go back to the field again, right? And if we can solve that, and in different kinds of use cases, it starts to get evolved. So we are using technologies, whether it's GPS denied, so that, hey, what happens if my GPS fails? What happens if my communication fails? How do I ensure that the flight system is redundant and I can finish my mission? Then the second part of it is what else kind of technologies we need to kind of support that. How do I make the data transfer go faster? Can I take more? Am I limited by the number of pictures I take, or am I limited by how quickly can I take? And so today we use SD cards, and they have a frame rate of how like you save it every second or two. In some cases you want to be able to take more images if you want much more higher accuracy, and you want to take it quicker. Then you need a better storage technology, right? So we look at all this and try to put that into a roadmap of development, and one is build the technology, second thing is build it into a product, right? So one of the, on Shooting Star, for example, we built that to do a light show, right? And there, one of the things to do a light show is you need to fly fleets and hundreds of drones or even thousands, right? And so the technology there was built as, how do I manage a fleet? How do I manage a swarm? Now that capability can also work with a drone like this. If I want to kind of do, if the customer wants faster inspection, and if I have to, scan a large bridge or a large area, then, I have to fly one drone 10 times, or can I fly 10 drones once? So, and it again has different pros and cons, but the capability is what allows you to do that. And what we learned from Shooting Star, for example, can be applied to managing, I'd call a fleet of commercial drones as well, right? And then the last part about it is in other kinds of applications, whether it is search and rescue or some other aspects of it. So, and then for learning from here for the light shows is, how technology can be more robust. And we have more accuracy. For example, RTK is more developed here. Can I make light shows more denser? How can I bring something like that into a light show system? So today we fly like at a meter and a half separation from the drones, and that's literally because of GPS, right? So then you're looking at, okay, how do I use something like RTK, which is giving you precision navigation here? Can that be miniaturized and scaled into something as light as a Shooting Star drone? So those kind of cross-pollinate each other, right? And then the last one, in both cases, a lot of places we see is a need for something indoor, right? You want to do like airplanes, they're at airports, and outdoor inspection sometimes becomes problems on getting airspace permits. And they want to see, hey, can I inspect a drone, use a drone, inspect an airplane in a hangar? I mean, very simple problem, except that you have no GPS. So, and we need to go figure the technology to make sure that it can reliably fly in a non-GPS environment. So, and so with the light shows, while we can do light shows outdoors, there are lots of concerts, theater shows, many artistic events where you want to bring that experience, have an interactive lights and dancing lights and show performers. And if you can have the immersive experience for the audience, it creates a whole different application of entertainment. So there, to again fly indoors, you need to have the technology. So kind of we invented or basically built out technology. Invention is a very strong word. The technology exists, but then we really built it and refined it, and we flew 110 drones at CES indoors over the audience and gave a phenomenal light show. So that same technology again can be used for a hangar inspection or an inspection of a tanker where you have situations where you have no GPS. Yes, we announced it's a 50th year anniversary for Intel. It's a proud moment for us. And we wanted to celebrate, and for us from the drone team, and saying, hey, what better than to give them a record-breaking event to remember with. And so stay tuned. But we said it'll be over 1,500 drones, and I can't wait to light up the skies.
Thank you so much, Anil, for taking the time to spend with us, and thank you for all of the presentations you did through Xponential this year. We learned a lot about the industry and a lot about the challenges facing the UAS market moving forward. I hope you guys are still with us, and thank you for sticking around. Give us that thumbs up if you like what you see here, and as always, make sure you hit that bell icon when you subscribe to make sure you see what we have coming next. Thanks again, all. Fly safe.